Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson about the volume of a revolution. Last time, we learned how to find the area of a region bounded by two curves. Today, we will explore how to calculate the volume of a solid by considering cross sections. We will also discuss solids of revolution and how these concepts can relate to real-world problems. If you are all ready, let us begin. Let us observe the curve. There is nothing very special about it. We have solved many problems involving curves like this in our classes. But suppose we were to rotate it in a straight line. You see that a new figure is formed. It looks a bit like a pot or a wide-mouthed tube. This new figure is called a solid of revolution. In general, it is a three-dimensional object that is formed by rotating an area around a straight line called the axis of symmetry. If we calculate the space inside a solid of revolution, we can say that we are calculating the volume of revolution. Let us find out how to do that now. The first fact we must know is the area of the cross-section. Lucky for us, this is easy to discover. Every cross-section which is perpendicular to the x-axis at x is a circular region with a radius equal to f of x. This way, we know that the area of the cross-section is pi r squared, equaling pi times f of x squared. Now that we know the area of a given cross-section, we can begin. Let us divide the solid of revolution into a number of equally spaced cross-sections. We will call this number n. The more cross-sections we take, the more accurate our measurement will be. Eventually, the sections we take will be rather like a cylinder. Remember that the length of a cylinder is represented by delta x. We will call the number of any given section k. That means that the volume of a given section is called VK. We can then say that VK is equal to this formula. If we are to calculate the total volume of the revolution, we must add all the different sectional volumes together. That is expressed by this formula. Please be sure to make a note of it. Now we are ready to calculate the total volume. The equation is expressed here. You see that the volume is expressed by delta V times the limit of delta x approaching 0. This is a tricky equation, so be sure to copy it down carefully. Now, I will ask you to try to calculate the volume of a revolution. To make it simpler, I will make it a very basic function to calculate. I will even give you an idea of what the function looks like. This way, I hope you will not have any problems. Please get started now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did you manage to calculate the volume of revolution? I hope that you were able to master these new ideas. Let us look at the correct answers together. This is what the solid of revolution looks like. We can calculate its volume with this integration. If you followed the steps properly, you will see that the volume of revolution for this function is 9 pi. We can use this formula to find answers to questions in the real world too. Let us say that I have a large spherical bowl of water. The radius of the rim of the bowl is 5 meters. The water in the bowl has a radius of 4 meters and has a maximum depth of 2 meters. Given these facts, how can we calculate the volume of the water in the bowl? We can solve this with the formula for calculating the volume of spheres. It looks like this. Please note it down. Now, we will apply the formula to solve the problem of the bowl of water. The first step is to graph the function. We know that x squared plus y squared is 25, and that x intersects at 5 and -5. We also know that y intersects at -5. Let us graph the result. When we draw it like this, the problem becomes easier, does it not? Let us see if you can use the formula for spheres to solve this problem. Please go ahead and see how you do.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us see if you were able to calculate the volume of revolution. Pi is integral from -3 to -5 of the square root of 25 minus y squared with respect to y. This simplifies to pi is integral from -3 to -5 of 25 minus y squared with respect to y. When we integrate the equation, it equals pi times 25y minus y cubed over 3. Y equals -3. So, when we substitute -3 into our equation, we find pi times 25 times -3 minus -27 over 3 minus -125 plus 125 over 3. This equation simplifies to 52 over 3 times pi. Therefore, the volume of the water in the bowl is 52 pi over 3 pi centimeters cubed. That is all for today, students. So far, we have learned about the areas bounded by two curves, solids of revolution and volumes of revolution. We have also begun to see how these concepts can help us solve difficult problems in real life. Next time, we will study the motions of particles in straight lines. Until then, thank you, teacher. Thank you, students.